Hey, Calc students, kind of a short lesson this week, just one video and a short assignment. Hopefully you've enjoyed a little bit of a break that you should have had this past week. Just a note, it sounds like you guys got home a letter about AP exams. You know now that the AP exams are not required for you to take as they have been in previous years. I just want to let you know that if you would like to take the AP Calculus exam, please reach out to me. So there's definitely a lot of free response questions that we could go over and a lot that you would fully understand. Um, I have not taken time to directly prepare for it in class. A lot of the content that we have is content on the AP exam. However, the truth is that this year they will all be free response questions. And those free response questions are not necessarily things that you're going to see in the future in college. So if you do want to take it, let me know. I have plenty of resources. I'd be happy to do review sessions for you. But for most of you, I'm guessing you're not going to be taking it. So, but let me know one way or the other if you would like to. Okay, integrals of inverse trig form. So maybe you remember that if you take the derivative of arc sine, you get 1 over the square root of 1 minus x squared. And so therefore the antiderivative of that gives us arc sine. The antiderivative of 1 over 1 plus x squared is going to give us arctangent of x. And the antiderivative of that 1 over x times the root of x squared minus 1, is going to be arcsecant of x plus c. If this was negative, then it would be inverse cotangent. If this was negative, it would be cosine. If this was inverse, it would be cosecant. Okay? So, using those, we're going to do a couple examples. Look at the integral of eight x over the root of 9 minus 16 x to the fourth. Okay? So the important thing in this situation is to recognize it fits the form integral of 1 over the root of 1 minus x squared dx is sine inverse of x plus c. So that's the form that we're fitting. We need to make it look like that. In order to make it look like that, we have to factor something out. We can't have a 9 there. So we're going to factor a 9 out of the square root. And so we get the integral of 8x over, when you factor a 9 out of the square root, it becomes a 3. You'll be left with a 1 minus 16 over 9 x to the fourth. So again, I factored that 9 out. It became a 3. Now you also see that it has a perfect square. This is a perfect square. So therefore, I have the integral of 8x over 3 roots of 1 minus 4/3 x squared squared. So what do you multiply by itself to get 16 over 9x to the fourth? You multiply it 4 over 3 x squared. Now we can go ahead and make our substitution. U is equal to 4 over 3 x squared. So therefore du, if we multiply by 2, we get 8 over 3 x squared dx. I'm sorry, not x squared, just x dx. Do you have an 8 over 3 x dx? Yeah, we have an 8 over 3 x dx. The substitution works out perfectly. So therefore, we replace 8 over 3 dx with du. So we have the integral du. What's left is 1 over the root of 1 minus u squared. We all know that that is equal to arc sine of u. What is u? It is 4/3 x squared plus a constant. There you have it. Let's try a couple more. Okay, as you look at this one thing to recognize is that it would never be written like this. It would be written as just an x in the denominator and not x squared over x cubed. But we write it like that in order to show you the hint that we're going to come up with. We want to find that antiderivative. Hopefully you recognize it's of the form 1 over x roots of x squared minus 1 dx, which is equal to secant inverse of x plus c. So we're looking at an inverse secant option here. Again, what we need is we need that x, squared, and I need a perfect square there. And so the perfect square will be x cubed. So I have the integral of 3x squared over x cubed roots of x cubed squared minus 1. So notice how this is your perfect square right there, because you have to have a perfect square. All right? Also notice the thing that's being squared, x is being squared, is what sits there. The thing that's being squared is what sits right there. We look at what u is equal to x cubed. So du is equal to 3x squared dx. Do I have a 3x squared dx? Yes, I do. Now the truth is that originally the problem would not have looked like that. It would have looked like this. But if you simply just, I'm sorry, there would be a 3 there. But if you would simply just multiply the top and bottom by x squared, you would then create that piece. So that's a little trick. We didn't start that from the beginning because I didn't think you would recognize that. So there you have it. We now have our substitution. The 3x squared dx goes away. I'm left with the du, and I have 1 over. What do I replace with this x cubed? I replace with u. What do I replace this with? I replace with u squared. And the antiderivative of this is secant inverse of u, and u is x cubed plus a constant. Just 2 more. 20x cubed over the root of 25 minus 25x to the 8th dx. Hopefully you see that this form is going to be the integral of 1 over the root of 1 minus x squared dx, which is sine inverse of x plus c. That's the form we're going for. So we need a 1 and we need a perfect square. How do I get a 1? I factor out 25. When you factor out 25 out of the square root, it becomes a 5. So you'd be left with 1 minus just x to the 8th, or x to the 4th squared. X to the 4th squared. What is u in this situation? U is x to the 4th. du is 4x cubed dx. Do you have a 4x cubed dx? You do. 20x cubed over 5 is the same as 4x cubed dx. So I have the integral, I have my du. That gets rid of that, and that. I'm left with 1 over the root of 1 minus u squared, which we said was inverse sine of my u value, x to the 4th, plus a constant. Last example. There is no square root in this situation. Hopefully you recognize it's of the form 1 over 1 plus x squared dx, which is arctangent of x plus a constant. That's what we're looking for. Notice in this work right here that you want to create a 1. If you'd like to create a 1, factor out 16. I'm going to put the 1/16 out front here. I'm left with a 1, and then I'll be left with 25 over 16 x to the 4th dx. Now, we have a perfect square right here. What do you square to get 25 over 16 x to the 4th? Well, 5 over 4 x squared quantity squared. So that's what we're going to choose to have for u. U is equal to 5 over 4 x squared. So du is equal to 10 over 4 x dx. Now, let's look at what we have. I don't see a 10 over 4 x dx. I see the 10x, I see the dx, but I see it divided by 16. Here we're just divided by 4. So how do I create 10x over 16? I'm going to multiply this by 1/4. 1/4 du is equal to 10x over 16 dx. Now I have my appropriate substitution. This is gone, and this is gone with the substitution of 1/4 du. What remains in its place? 1 over 1 plus u squared. The antiderivative of that is, as we said, arctangent of, what is u? U is 5 over 4x squared. You have your 1/4 out front plus a constant. And there you have it. So I know that's not easy. I'm going to try to give you examples for your assignment that follow directly along with what you've seen. But it's good to just get back to some of those integrals of inverse trig form. Just kind of one small lesson on that. And then after this, you'll be looking at integration by parts. So this is really your second to the last piece of content that you have before the end of the year. We'll look to one more piece, which will be integration by parts. And then after integration by parts, you'll have your final test, and it will all be over with. So I hope you've enjoyed the calculus as much as I have. I did get a chance to reach out to a couple of you last week. I enjoyed that. Please feel free to go ahead and ask questions. And even if you don't have a question, just ask to meet. I'd love to be able to sit down and chat with you. Have a great day. Be a tiger.